Morning. I am Dr. P. Usha Rani, Professor, Triple S&H Department, RMT Engineering College. I am going to brief about the topic of Maxwell's loop current technique. The other name for Maxwell's loop current technique is mesh analysis. Here, which is a circuit analysis technique used to find currents circulating around a loop or mesh within any closed loop of a circuit. So we are using Kirchhoff's voltage law, which is applied to a network to write Maxwell's mesh equations in terms of mesh currents. Instead of branch currents, we are going to write the mesh currents. Here each mesh is assigned a separate mesh current. So this mesh current is assumed to flow in the clockwise direction around the perimeter of the mesh without splitting at a junction into branch currents. After that only we are going to apply Kirchhoff's voltage law to write the mesh equations in terms of unknown mesh currents. So while writing mesh equations, we should keep that in mind. That is, rise in potential is assigned as positive sign and a fall in potential is assigned as negative sign. So if you know mesh currents, we can find the branch currents by adding the algebraic sum of these currents. So I have taken one example problem. They have given a circuit having a voltage source of 5 volt, and the branch resistors 10 ohm, 10 ohm, 10 ohm, 2 ohm, parallel resistor 2 ohm and 20 ohm, and another voltage source at the end 10 volt. They are asking determine the voltage across this 20 ohm resistor in the network shown in figure by Maxwell's loop current method or mesh analysis method. This is the circuit given. I have taken 3 loop currents. I1 in the first loop A, B, C, D, A, and for the second loop I have taken C, E, F, D, C. I2 was the mesh current, and third loop E, G, H, F, E, I3. So I am going to write the loop equations, okay, for the concerned loops, each loop. So first loop, this A, B, C, D, A. So if you consider that this 10 ohm, so I1 is the current through that. So I am writing the sum of potential drops, which is equal to 0. I am applying Kirchhoff's voltage law. So 10 into I1 plus 2 into the downward direction of current as I1 and upward direction I2. I am going to see the path of A, B, C, D, A. So I1 is positive and compared to I2. So I am writing 2 into current as I1 minus I2, and this value of voltage minus 5, which is equal to 0. So if you simplify that, I am having the equation 12I1 minus 2I2 equal to 5. This is my first equation. And the second loop I have taken as CEFDC. So here current as I2 is the loop current, but if you consider both the parallel resistors, one side I1, another side I3 is coming. So we should take care of these two currents. So I am writing the equations 10 times I2, and this 2 resistor current flows through that as I2 minus I3, plus here 20 into I2, and this current, this 2 ohm resistor. So 2 into I2 minus I1, which is equal to 0. There is no voltage source here. So only the resistance drops. So sum of the resistance drops I wrote here, and after simplification minus 2I1 plus 34I2 minus 2I3 equal to 0. This is my second loop equation. And considering loop EG, HF, E. We will start writing the equations. 10 times I3 current, loop current, plus 2 times I3 minus I2 minus of 10 volt, which is equal to 0. So for this loop, if you simplify, there won't be no I1. So 0 times I1 minus 2 times I2 plus 12 I3, which is equal to 10. So we have 3 loop equations for the concerned loops. After simplifying these 3 mesh equations, okay, we can find I1 as 0.429 amps, I2 as 0.075 amps, I3 as 0.8453 amps, and voltage across 20 ohm resistor as I2 is the loop current flows through that path, I2 into the resistor value 20. So if I multiply this, I am getting 1.5 volt. So by writing Maxwell's mesh equations using loop analysis method, that is mesh current technique method, we can solve the circuit. Thank you.